When you turn your eyes to the night, what do you see? Serenity, order, an infinite calm. The sky appears as a reliable clock, unchanged for billions of years. But this is a magnificent cosmic illusion, a fleeting moment of peace. In reality, every one of those peaceful points of light is a gargantuan nuclear furnace, careening through the galaxy at hundreds of thousands of kilometers per hour. They are not bound by static formations. They are constantly changing neighborhoods. Fortunately, space is vast. A collision is vanishingly unlikely. But a star doesn't have to hit us to cause our end. It only has to pass close by. And right now, some are doing exactly that. We owe our existence in this corner of the cosmos to a single force, gravity. Our sun accounts for 99.75% of all mass in our solar system. It is the undisputed master of this family. Its gravity is the invisible tether that holds the planets in safe, predictable orbits. But this was not always so. Before this balance, there was fire, billions of years of chaos, planets colliding, worlds wandering. Our solar system was a brutal construction site. What we see today is the calm after the storm, a fragile stability won over eons. The sun's kingdom extends far beyond the planets. At the furthest edge lies the Oort Cloud, a colossal spherical shell of trillions of frozen comets. This is the dark, cold storage of our system, where the sun's gravity barely hangs on. This entire structure, this delicate cosmic machine, is what we call home, and it is terrifyingly vulnerable. Why are these stars moving? Because our galaxy itself is a dynamic living thing. We, our sun, and all our neighbors, are orbiting its massive black heart, Sagittarius A star. And as we orbit, we weave through the traffic of other star systems. Most encounters are harmless, but sometimes the math is not in our favor. Its name is Gliese 710, a red dwarf star with about half the mass of our sun, and it is heading directly towards us. In about 1 million years, it will pass through the Oort Cloud. It will become the brightest star in our night sky. This visitor will disrupt that delicate balance, raking the outer system. It will dislodge millions, perhaps billions, of sleeping comets. If we are unlucky, this will trigger a new planetary bombardment, raining fire and ice down on the inner solar system, causing mass extinctions, the kind that wiped out the dinosaurs. This is a very real, and perhaps unavoidable, future threat. But it is not the worst-case scenario. It is not the end. What if a star didn't just graze the Oort Cloud? What if it passed closer? Imagine a star, perhaps a brown dwarf, something dark and massive, that cuts inside the orbit of Neptune. It wouldn't eject us. Not yet. But its gravity would pull and twist the orbits of the outer ice giants. Uranus and Neptune. Their orbits could become unstable. They could be thrown into the inner solar system, scattering the asteroid belt like shrapnel. Earth's stable orbit would become a cosmic shooting gallery. Survival would be unlikely, but it could still get worse. What if a star passed directly through our home, the inner solar system? It still wouldn't collide with the sun. That's not what we're worried about. If this star passed as close to us as the Earth is to the sun, the laws of physics would make a cruel choice. It is a battle of gravity. Our sun, our protector, suddenly finds itself in a tug-of-war with another massive body. And in this complex, three-body problem, there is no simple solution. Earth, caught in the middle, is thrown free. The sun's gravitational bond, which has held us for billions of years, would snap. Earth would be torn from its system, ejected by this cosmic slingshot. Our planet would become a rogue planet, an exile, drifting alone into the dark, into the interstellar abyss, and we would not be the first. Astronomers now believe there are billions, perhaps trillions, of these orphan worlds, floating in the cold dark between the stars. We would simply be the newest member of this lonely cosmic club. The odds of this, in the next 5 billion years, are about 1 in 100,000. Low, but not zero. So, if that day comes, what would our final days look like? It begins with a small orange dot in the sky. For months it grows, becoming brighter than the moon, too bright to look at directly. It fills our nights with an eerie red glow. Then, after a few months, it begins to shrink, but so does the sun. As Earth is cast out, the sun fades in our sky. With it, warmth and light dissipate. The final winter of humanity begins. The first thing to fail is life's engine, photosynthesis. The process that powers our entire biosphere stops. Without sunlight, plants can no longer make food. The great forest of the world, the lungs of our planet, die, and then freeze solid. They become glass-like sculptures, monuments to a world that was. The polar ice caps grow, relentlessly, advancing toward the equator. Animals perish in droves. The air becomes impossibly clear as all moisture freezes and falls. The silence is absolute, broken only by the crackle of the freezing oceans and the tectonic groans of a dying world. By the time Earth passes the orbit of Mars, the average surface temperature has plummeted to -50 degrees Celsius. From space, Earth is no longer an oasis of blue and green. It is a pale, gray-white orb of death. Global infrastructure collapses. People huddle indoors, burning whatever they can for warmth, counting the days until the food, which no longer grows, runs out. Everyone on the surface always living on borrowed time. As Earth reaches the orbit of Jupiter, surface temperatures sink to -150 degrees Celsius, lower than the coldest temperature ever recorded in Antarctica. Needless to say, by now, almost everyone on the surface is dead. Without the sun's energy, the water cycle stops. No clouds can form. The oceans become covered by a thick sheet of ice, kilometers thick. Is all life gone? Not quite. Deep below the ice, miles down, where sunlight never reached anyway, life clings on. Around hydrothermal vents, volcanic chimneys on the ocean floor, extremophile bacteria thrive on the Earth's inner heat. For them, not much has changed. The Earth's core still burns. A radioactive heart encased in ice, it is this internal heat, a faint memory of our planet's violent birth, that offers the only hope. As we reach the orbit of Pluto, the sun is just one of many stars. The temperature is now barely 40 degrees above absolute zero. This is below the freezing point of our atmosphere. A strange spectacle, witnessed by no one, unfolds. The atmosphere begins to snow. First, nitrogen snow. Then, oxygen snow. Over a few years, the entire sky is deposited onto the surface in a 10-meter thick sheet of frozen gas. The frozen corpses of all flora and fauna are buried beneath it. Earth is now a dead planet, drifting alone in the dark, lifeless, and in solitude. But, weirdly enough, there is a sliver of hope. This catastrophe would not surprise us. We would see it coming, thousands of years in advance. We could not stop it, but we could prepare. Most of us would perish, but perhaps a few million could survive in vast subterranean complexes, dug deep into the Earth's crust, near those geothermal vents, powered by geothermal energy from Earth's still molten core, and by nuclear, or even fusion, power. Here, deep beneath the frozen crust, humanity might survive for hundreds of thousands, perhaps millions of years, they would be a new kind of human, a subterranean species. Their sun would be the glow of the reactor. Their farms would be vast hydroponic vats or synthetic protein printers, recycling every atom. Their sky would be the rock ceiling above them. Their children would hear stories of the surface, a mythical place where you could walk under an open sky and feel the warmth of a star on your face. They would not believe it. It would sound like magic. And at some point, we might decide to look for another home. If the Earth, by sheer luck, passed by another star, one with a habitable planet, we could try to make a fresh start. Spaceflight, oddly enough, would become very easy without an atmosphere in the way. Perhaps the last survivors would leave their frozen home and try again on a new planet, around a new star. Maybe one day, thousands of years later, the descendants of humanity will tell legends about Earth's ancient past, stories of our lost home, of a mysterious icy planet floating alone and empty. Through the dark of space, a ghost of a world that once was, a silent testament that even the most perfect garden can be reclaimed by the cold, cosmic wilderness. If you wish to support our mission of mapping these complex journeys through history, Chrono, and science, Cosmos, consider subscribing. Or, if you are able, support us directly. It allows us to continue building this library of knowledge. Thank you for watching.